So our next presenter is Jun Huang, diverse rock types detected at the Lunar South Pole-Aitken Basin by the Chang'e 4 mission. Again, I'll do an alert at 8 minutes, 10 minutes, and then 12 minutes we'll move on. Take it away.
Hi. I should say good morning. Actually, it's night here. So today I'm going to present some results of Chang'e 4 mission. We detected different rock types near the landing region. If you need more detail, please read our paper published in Geology. So the name of the mission is Chang'e, not Change, not Chang'e. Even back in Apollo times, there was jokes about the beautiful lady. So for the Chinese lunar exploration programs, there are 3 phases. First is orbiting, which consists of Chang'e 1 and 2, and then landing, which includes Chang'e 3 and 4, and this year Chang'e 5 and will be launched and collect a sample from the near side of the moon. But today we will focus on Chang'e 4. As you all know, if you want to land something at the backside of the moon, you need a relay satellite. So the relay satellite Chang'e was launched 2 years ago, and then 1 year ago, the lander and the rover was launched, and it successfully touched down on January 3rd, 2019. There are several instruments on the lander and the rover, and today we are going to talk about some data acquired by the descending camera, parametric camera, topographic and geologic camera, and the visible and near infrared spectrometer. As you know, there are several interesting questions remained for the far side of the moon, especially for the giant hole at the far side. First is there any lower crust or upper mantle materials exposed? The second is, can we observe differentiated impact melt sheet? And the third is, what's the composition look like for the far side melt basalt? As the landing side within a crater named Von Karman at the north west of the SPA crater. As you can see from the orbital data, the very superficial material for the landing side is probably from the impact crater Basin, just northeast of the Von Karman crater. And what can we tell from the in situ observations? Can we see mantle materials? So we will talk about the first 4 days results for the rover, which has been traveled almost 500 meters now, but today we only focus on the first 200 meters. As you are all familiar with the spectral, you can see here we show the spectral of the regolith observed in the first 4 days. And in this small picture here, this is the footprint of the sphere detector, and you can see the red slope of the regolith and the features around the 1 micron and the 2 micron. We collaborated with Paul Lucy, and use the mineral lookup table, we remove the continuum between 750 to 1550 nanometer, and we fix the grain size to 17 micron, and we set the MG number to 65, and we use 4 methods to evaluate the spectral fit. So we plot the mineral abundance to the program to the plots above, and as you can see, there's some variations, but most of them are dominant of plagioclase and pyroxene. And as you can see, our results about the mineral abundance observed in situ is consistent with the previous work by our colleague using Kaguya and my data using similar mineral lookup table approach. So let's switch gears to the cameras. As you all can see in this picture, we see 2 groups of rocks with different tons of tons, and one group is dark tons, like this one in the middle, and we zoom it in with the image, and you can see there are some white spots on the dark rock. It could be plagioclase, finalist, or they can be pits created by micro impact. Unfortunately, we didn't take visible and near IR spectral of this rock because the rover was busy doing check and taking images to the lander at that moment. So at the end of the second day, we encountered a bunch of rocks. One of them, in front of this bunch of rocks, we took a visible and near IR spectral of it. And this is the first in situ visible near IR spectral of a lunar rock. We named the rock informally as Yuan, which means unexpected encounter. So when we zoom in to the rock, and we can see similar white spot on the rock, which has similar explanation as I previously explained. And this is the image taken from the visible near IR spectrometer, and you can see the footprint of the sphere detector. Okay, here I show the spectral of the rock above the spectral of the regolith. As you can see, it's a rock, so it has relatively deeper spectral features around 1 and 2. So we try to analyze the spectral quantitatively. So we remove the continuum, and we compiled the spectral to the spectral available for the Apollo samples. And as you can compare the center locations and other spectral features I will mention later, we found that the spectral is similar to materials with dominant pyroxene and plagioclase.
You're at 8 minutes, by the way.
Oh, thank you. So we compiled the spectral to the remote sensing MQ data as well, and we found similar results. And as you can see from the figure on the right corner, previous colleagues' results are similar to the results we found, and the materials from the ejector of Basin crater is similar to the landing side and to the in situ measurements. So we did some spectral analysis. As I mentioned before, we calculate the 1 microband asymmetry with the 1 microband center and 2 microband center and band area ratios, which means band area of 1 and 2. And so we plot all of this and we see the difference, the distance between the rock and all the selected Apollo samples. And we found out the rock Qiyuan is likely composed of pyroxene and feldspar dominant assemblage with at most minor olivine. So how should we interpret the implication of the rock? As we can see from previous work like Otaka 2014, at the center of SPA Basin, it's most likely there's a central depression, which may indicate most of the impact melt. And at the location of Von Karman crater, it most likely the ejector is ejected from the Basin crater, which is quite far away from the outline of and the impact.
You're at 10 minutes, by the way.
Yeah, so we think mostly the rock Qiyuan is like a representative of lunar crust, not from the mantle. So the take-home message is Qiyuan is likely from Basin crater, which is consistent with orbital observation, and Qiyuan and nearby regoliths indicate a mineral assemblage of feldspar and pyroxene. We don't see olivine-rich materials reported by our colleague. I will stop here and I'm happy to take questions. Thank you.
Great, thank you. We did have one question in the chat. I'd suggest actually you go ahead and answer because he's directly in the chat after your talk. So we have about 40 seconds if there's anyone who wants to raise their virtual hand and ask a question out loud.
Yeah, it's just Clive. Were you able to deduce a whole rock magnesium number? Because Otaki also suggested the crustal materials are higher in magnesium number on the far side than the near side.
It's a good question. I don't think we can derive an accurate number of mg now, but I think people are trying to derive the mg number. I don't know whether I answered your question.
That's fair enough. So future, more work to do.
Yeah, exactly. Thank you, Clive.